Something just happened behind the sun while every telescope on Earth was blind, and the data that's coming back is absolutely terrifying scientists. Look, I'm going to show you the actual images and data from this thing, and by the end of this video, you're going to understand why a Harvard professor told people to take their vacations before October 29th. Because what we're seeing now, it's not following the rules. But here's the thing nobody's talking about. This object traveled for 7 billion years to get here, longer than Earth has existed. And it arrived at the perfect angle, at the perfect time, hidden from view, at the exact moment it would be most active. Is that a coincidence or cosmic serendipity? Well, let me show you why that question is keeping astronomers up at night and why this are really heating up at the moment. Quick thing, hit that subscribe button right now, because in the next few days we're getting data that could literally rewrite physics and what we thought was possible. You're not going to want to miss what happens next. Okay, so here's what we know. On July 1st, 2025, a telescope in Hawaii picks up something weird, really weird. At first they think it's just another comet. Tag it, track it, move on, but then the math starts coming back wrong. This thing is traveling at 68 kilometers per second, faster than anything humans have ever built. And it's not from here, it's from another solar system entirely. Only the third interstellar object we've ever detected. They name it 3I Atlas. And that's when things get strange. Check this out. Its path through our solar system is aligned almost perfectly with the plane where all our planets orbit. The odds of that happening randomly? 1 in 500. But here's the crazy part, and I need you to really hear this. If you were an alien civilization designing the most efficient route to visit multiple planets in one pass, you'd choose exactly this path. But wait, it gets weirder. So scientists point the Very Large Telescope at this thing. Yeah, that's actually what it's called. And they break down the light coming off it to see what it's made of. And they find nickel vapor. Now, if you're not a chemist, you might be like, okay, so what? But here's why this matters. Nickel vapor at these concentrations. We've only ever seen that signature in one place on Earth. Advanced industrial processes. Specifically in controlled metallurgy when we're making high-tech alloys. It doesn't just happen naturally in space rocks. But okay, maybe it's some weird natural process we don't understand yet, right? Some exotic chemistry from another star system? Here's the problem. The nickel is concentrated in a 600-kilometer region, but the cyanide they also detected extends 840 kilometers. If they're both just ice melting off this thing randomly, they should have similar patterns. They don't. The nickel is acting like it's coming from specific points, like it's part of a structure, like something is organized inside this thing, and then, I swear this sounds like science fiction, but it's real data, they find something else that breaks the rules. Comets are basically dirty snowballs, right? Ice with some rock mixed in. Water should be like 40, maybe 50% of the mass. 3I Atlas has 4% water, 4%. The James Webb Space Telescope confirmed it. This thing is loaded with carbon dioxide, but almost no water. That's not how comets work. That's not how any natural comet we've ever seen behaves. Now here's what's really messing with scientists' heads. Remember Borisov? The previous interstellar comet from 2019? Everyone agrees that one's natural. It had totally normal water content. Standard comet stuff. So why is 3I Atlas so different? Two objects, both from interstellar space, one normal, one not. And we're not done. Because between July and August, this thing did something that made astronomers literally question their observations. It grew a tail that points the wrong direction. Comet tails point away from the sun. Always. That's like basic astronomy. Solar radiation pushes the dust and gas away from the sun. It's not complicated. Except 3I Atlas said, nah, I'm going to break physics. It developed an anti-tail. Material ejecting toward the sun. Uphill, against the solar wind. And before you say it's just an optical illusion, a perspective trick, scientists checked. They triple-checked. Material was genuinely being pushed against solar radiation pressure. Something inside this object was generating thrust. Okay, so let me recap where we are, because this is where it gets real. Perfect trajectory for visiting multiple planets. Check. Industrial chemical signatures? Check. Wrong composition for a natural comet? Check. Active propulsion against solar wind? Check. And this is all before the thing disappeared behind the sun. Now, I need to tell you about what happened when we couldn't see it, because this is where the story takes a turn. Okay, this is the part that gives me chills. October the 21st, 3I Atlas moves into what's called solar conjunction. Basically, it positions itself on the exact opposite side of the sun from Earth. For 8 days, every single telescope on Earth is completely useless. We can't see past the sun's glare. It's like trying to spot a firefly next to a spotlight. October the 29th, 11:47, AM UTC, perihelion, closest point to the sun. And at that exact moment, this thing is being hit with 33 gigawatts of solar radiation. That's 1/3 of all the nuclear power plants in the United States, concentrated on one object. For context, that's enough energy to power every home in California, Texas, and New York combined. This is the most intense energy this object has experienced in its 7 billion year journey through space. And we can't see any of it. Now, here's what really freaked out some scientists, and I need you to understand why this timing is so suspicious. Avi Loeb, Harvard professor, literally told people, if you want to take a vacation, take it before October 29th, because who knows what will happen. And he wasn't joking, because if you're a spacecraft, if you're anything with the ability to maneuver, perihelion is the perfect moment to do it. It's called the Oberth effect. When you're moving fast and close to a massive object, any thrust you apply gets multiplied by orbital mechanics. Every space mission to the outer planets uses this trick, so think about this. An object with 8 documented anomalies, already defying explanation, passes through the point of maximum solar energy during the only window when every telescope on Earth is blind. Coincidence? But here's the thing, and this is where it gets insane, we weren't completely blind. See, while Earth-based telescopes were useless, we had a few spacecraft scattered around the solar system with different viewing angles. Weather satellites, solar observatories, instruments never designed to track comets. They're meant to study the sun's corona. But scientists turned them all toward 3 Atlas. And what they captured changes everything. October the 28th, one day before perihelion, the data starts coming in. 3I Atlas is brightening. Fast. Way faster than it should. When we last saw it clearly in early October, it was magnitude 11.5. Too faint for the naked eye, barely visible to backyard telescopes. But now, by perihelion, it hit magnitude 9. That's about 10 times brighter than predicted. But that's not the weird part. The weird part is how it's brightening. The rate of increase is scaling to the power of negative 7.5 with distance from the sun. That's aggressive. That's not normal comet behavior, that's massive outgassing, like this thing is shedding material at an insane rate. And then they notice something else, something that shouldn't be possible. The color? Okay, physics 101. Hot things glow blue. Cold things glow red. The sun's surface is 800 degrees Kelvin, so it looks yellowish white. 3I Atlas is 203 million kilometers away. Its surface temperature should be about 20 times cooler than the sun. It should look reddish, dusty, dark, but it's glowing bluer than the sun. That's not how reflected light works. That's not how cold objects work. For a comet to appear bluer than the sun, something else has to be happening. Something that's generating its own light. Something hot. And then, I kid you not, on October the 30th, Avi Loeb drops a paper with a title that made the entire astronomy community lose their minds. First evidence for a non-gravitational acceleration of 3I Atlas at perihelion. The orbital math shows it. This thing isn't following pure gravity anymore. Something is pushing it. 2 possibilities, only 2. Possibility 1, this comet is literally tearing itself apart, evaporating so violently that the rocket effect of all that escaping gas is changing its orbit. If this is true, if it's shedding that much material, it would lose about 10% of its entire mass over the next month. Billions of tons of ice and rock blown into space. That kind of mass loss would create a plume so big, so obvious, that every telescope pointed at it would see it immediately. So when we look at it again in mid-November, we'll know. Possibility 2, the acceleration isn't from evaporation, it's from propulsion, an engine. Alright, so here's where we are right now, at this exact moment while you're watching this. 3I Atlas is currently about 210 million kilometers from the sun and moving away. Fast. Every second, it's getting 68 kilometers farther from us. The blackout is over. The waiting begins, and over the next few months, we're about to get answers. Or at least some of them. November 3rd, that's in just a couple days, it passes Venus, 97 million kilometers away. Close enough for serious spectroscopic analysis. November 4th, the European Space Agency's JUICE probe, which is on its way to Jupiter, gets its closest look. It'll be about 64 million kilometers away, which in space terms is basically right next to it. Here's the frustrating part. JUICE is using its main antenna as a sun shield right now to protect its instruments. So it can observe, but it can't send the data back to Earth until February 2026. So we got to wait again. But mid-November, that's when things get real. 3i Atlas comes out of the sun's glare. We can finally see it again from Earth. Every major observatory on the planet will be pointed at this thing. And here's what everyone's looking for. Is there a massive gas envelope? Did it lose that 10% of its mass? Did it fragment into multiple pieces? Are there secondary objects, smaller pieces that weren't there before? Because if it released anything at perihelion, probes, fragments, whatever, they'd be on slightly different trajectories by now. We'd be able to spot them. December the 19th. Mark your calendar. That's when 3i Atlas makes its closest approach to Earth. Still 269 million kilometers away. Totally safe. Not going to hit us, but close enough that Hubble, James Webb, and literally hundreds of ground telescopes will have crystal clear views. This is the moment of truth. And then March 16th, 2026, Jupiter encounter, and NASA's Juno probe will be waiting. At 54 million kilometers, Juno's going to image this thing in detail and use its radio antenna to listen, just in case. Now, I got to be real with you, the scientific community is absolutely split on this. Most astronomers, like the vast majority, think 3i Atlas is a natural comet. Weird, definitely. Teaching us that interstellar comets can be wildly different from our own, but natural. Jason Wright from Penn State published a whole breakdown of Loeb's analysis, basically saying, look, these anomalies aren't as anomalous as they seem. He argues the size estimates are inflated, the chemistry is unusual but not impossible, and Loeb is jumping to conclusions. Wright also points out that Loeb keeps publishing this stuff in blog posts and media interviews before peer review, which in science is kind of a no-no. Loeb fires back saying peer review is too slow for events like this. By the time papers get approved and published, the comet's gone. And he thinks the scientific community has a serious problem with paradigm shifts, that they're too quick to dismiss anything outside the box. Here's what's not up for debate though. The brightening happened. The blue color is real. The non-gravitational acceleration is in the data. The nickel vapor is there. The 4% water content is confirmed. These are facts. The question is, what do they mean? And honestly, that's what makes this so fascinating, because both explanations, natural or artificial, are profound. Think about this for a second. If 3i Atlas is artificial, if it's technology, then it was built 7 billion years ago. Before Earth existed, before our sun finished forming, before the solar system settled into the configuration we know today. We're not talking about a civilization a few hundred years ahead of us. We're talking about a civilization so ancient that the entire history of life on Earth, from single cells to you watching this video, would be like a single frame in a movie to them. But if it's natural, if every anomaly has an explanation we just haven't figured out yet, then the universe is way more creative than we thought. Chemistry can do things we've never seen. Matter can organize itself in ways that look designed, but aren't. Either answer changes everything we thought we knew. And here's the thing that keeps me up at night. We're only just now becoming good enough at this to notice these objects. The Vera Rubin Observatory just came online this year. It can scan the entire sky every few nights and detect things fainter than ever before. Within the next decade, we'll probably find dozens, maybe hundreds of interstellar visitors passing through. The question isn't whether they're out there. The question is whether we're ready to know what we'll find. Look, by mid-November, literally in the next couple weeks, we're going to see 3i Atlas again. We'll know if there's a massive gas plume, we'll know if it fragmented, we'll know if there are multiple objects where before there was one. And I'm going to be covering every single update as it comes in. Because this This is the biggest space story happening right now, and most people have no idea it's even going on. Next video, I'm going to break down the JUICE flyby data when it comes back in February. We're also going to look at what other interstellar objects we've found and why this one is so different. So here's what I need you to do. Hit that subscribe button and turn on notifications. Seriously, click the bell, because when that data drops in the next few weeks, you're not going to want to miss it. Drop a comment below with your take. Natural comet? Or something else? I want to hear what you think. 3i Atlas travelled for 7 billion years to pass through our little corner of space. It's leaving now, accelerating back into the darkness. But for this brief moment, we got to see it, study it, wonder about it. And the question isn't just what it is, it's what we'll discover when we keep looking up.